Last week we started looking at diodes and some of the fun things that can be done with diodes, and we mentioned that all diodes emit light, even though a lot of times you can't see that. But what that makes possible is the light emitting diode. So this week we're looking at light emitting diodes. Let's start by looking at the various sizes that these things come in, because boy do they come in a variety of sizes. Now they do come in some really large sizes and some really bright light outputs. They're used in automotive industry and that sort of thing, but the most typical LED is the 5mm LED. But they also come in a 3mm size, which is also quite common. And you can see here a much smaller 1.8mm LED. But if you really want to get small, there's the surface mount LED. Now these are intended to be soldered directly to a circuit board, hence the name surface mount LED, but you can purchase these already soldered to a little tiny piece of circuit board with some pigtails attached so that you can hook it up to power. And boy, do these get small. Some of these are just practically microscopic, and so you can fit them in some very unusual places. They also come in a whole variety of different colors. Of course, mostly what we want to use is a white light, a clear light, but you can purchase them in all kinds of colors, and sometimes you will see that they're tinted a certain color. The tinting isn't what supplies the color. The color is built into the LED itself. The tinting is just there so that you can see what color the LED is when you're pulling it out of your bin. Most of the colored LEDs, however, are just clear, so the only way you can find out is keep them labeled properly or just turn it on and see what color it is. Now, unfortunately, the hardest color to achieve is just good old incandescent bulb white. You can buy them that say they're warm white, and that's about as close as you're going to come, but none of these things actually look like a nice warm incandescent bulb. Now here's our first deep dive into complete nerddom. These are spectra of different light sources. So you can see there in the upper left is daylight. That's what sunlight looks like as a graph. And right next to that is the incandescent bulb. And that's sort of what we'd like to be able to achieve with an LED. But unfortunately, the first just sort of clear white LEDs, if you will, are called cool white LEDs. And they're sort of more intended to duplicate daylight. But you can see by the spectra it isn't actually daylight, and they come off looking just kind of bluish. Now there in the lower right hand corner is warm white, and that is supposed to duplicate what we see over there under incandescent. And again, you can see that it's close, I guess, but it's not right. So here's a nice side-by-side comparison. On the left there is an actual incandescent from our show on rebuilding the Delton fire wagon. And on the right is one of those screw-in LEDs in a warm white color. And you can see that it's a much colder color. It doesn't have that warm glow of the incandescent. Moreover, it's such a tiny, bright pinpoint of light that it casts really hard shadows, and it just creates a much harsher light than an incandescent bulb. And so for that reason, I still use an awful lot of these little incandescent lamps. They're expensive, but they're worth it. A lot of times the LED just doesn't look right, so I'll use one of these small incandescent lamps. So the question often comes up, how can I dim my LED? It's just simply too bright. And the easy answer is, well, you can't. But there's a more complicated answer that says, well, sometimes kind of, sort of. First, we need to understand something about an LED. LEDs are not rated in voltage, they're rated in voltage forward. And what that means is how much voltage does it take to turn the darn thing on. Remember, an LED is just a switch, and it hits a certain voltage and it switches on. And so at that point, the voltage forward is represented there in the circuit. It is being used in the circuit, but everything beyond that point is just being passed through there, just like a switch that's been turned on. Essentially, it's a short from that point on. So if you reduce the voltage lower than the voltage forward, it will slightly sort of dim and then it just goes out. But there's no way you can land on that sort of sweet spot just as the voltage forward is turning the thing on and expect that to work. It's just basically going to be on or it's going to be off. Now, you may have noticed in the stores when you buy LED replacement light bulbs, just to put in your lamps and stuff at home, some of them will say dimmable. And what that means is the LED driver inside there is a very complicated little bit of circuitry designed by an engineer that went to MIT that has figured out how to get your light bulb to talk to the dimmer on the wall. But my degree is from MIT, KEYMOUSE, so no, it's just not possible. But there is a trick, or sometimes known as a hint. I know the popular current vernacular is hack. Hack is what you actually do with an axe. So I'm not going to use that expression. I'm going to call it a trick. Anyway, if you want your LEDs to not come on quite so bright, instead of running them on DC, you can run them on AC. And then they're only on half the time. They're flashing on and off 60 times a second. And that can be a little annoying when you're trying to take video and so on. But generally speaking, you won't notice it. What you will notice is that your LED is quite a bit dimmer. And we need to keep in mind at all times that normally we're not running these things on AC. And so when we're running them on DC, we need to make sure that we're hooking them up with proper polarity or they're not going to come on at all. Okay, now unfortunately we have to take sort of a deep dive into geekdom or nerddom in order to figure out how to properly power an LED. Because again, they're effectively just a switch, an on and off switch. And so if you treat them the same way you treat them as a light bulb, either they're not going to come on at all or they're going to come on for a few seconds and then burn out. It is possible to run them by simply finding out what the voltage forward is on your LED and then feed it just slightly over that voltage. That'll cause them to come on, but they won't be given enough voltage to create high amperage in the LED and burn them out. So that's one way to deal with it, and we'll come back on that in a minute. The downside is a lot of LEDs have different voltage forwards, and so unless you want to have 10 different power supplies to feed all of these different voltage forwards, that's just not a very good option. So there's a much better way of dealing with it. Since an LED is essentially just an on-off switch, once it hits its voltage forward, it just turns on. So if we put a load in that circuit, it will act just like a switch that's turning on that load. An on-off switch turning on a particular load, in this case represented by a simple resistor. I mean, technically it could be any load like a light bulb or something, but the simplest way is to just grab a resistor and put that in the circuit. Now we also have to know what voltage we're going to be running this thing on so we can figure out exactly what resistor we need to put in the circuit to make the whole thing work. So we asked our good friend Don, who is an electrical technician who worked in the military industry and designed and worked on the design of data links for drones and stuff like that. So he knows his way around all this stuff. So we had him explain it.
So you take a volt and a half was what the LED wants.
LED is dropping a volt.
So 9 volt, you take a volt and a half, that leaves you 7.5. You take the 7.5 and divide it by what you want the current through the whole circuit to be. So let's say 20 milliamps. You take 7.5 volts and divide it by 0.02, which is 20 milliamps, and that becomes the total resistance that you want to put in the circuit.
Okay, so I listened to that like 70 times, and I finally was able to figure out exactly how this works. And actually, it's not really complicated at all. It just sounds complicated. So here's our LED, and it's rated at 3.2 volts forward, and it's also rated at 20 milliamps, or 0.02 amps. So if we feed it more amperage than that, it's going to reward us by burning up. But it's going to take 3.2 volts just to turn it on. When you buy these LEDs, quite often there's a data sheet, and it'll explain what these numbers are, what the voltage forward is, and what the amperage is that it wants to see before it actually burns up. Sometimes, of course, you don't have the data sheet, and so you have to figure this out with your meter, or my technique, guess. Now, we're going to be running this on our 12 volt power supply that we're running all of our lights on. So if we run the 12 volts over to the LED will reward us by burning up. So we have to put a load in the circuit. And now, how do we figure out what resistor to stick here? And that's going to require a wee bit of math. So the voltage forward is 3.2 volts. Once we hit 3.2 volts, the diode switched on and the light came on, but also at that point it started passing current through the circuit. So that means that 3.2 volts is actually being used up in the circuit. Now we just need to use up the rest of it. So if we subtract the 3.2 from the 12, that leaves us with 8.8 volts. Now our LED doesn't want to see any more than 20 milliamps, or it's going to burn up. That's 0.02 amps. So we need to divide 8.8 by 0.02, and that comes out to 440. So we need to put a resistor in there that's 440 ohms, and it'll be fine. So it's pretty simple math. In other words, you can just ask your phone. So let's figure it out now for a 9 volt power supply, and we say, hey phone, how much is 9 minus 3.2? And it says that is 5.8. And then we say to our phone, how much is 5.8 divided by 0.02? And it'll say 290. In other words, if we want to run our LED on 9 volts, we need a 290 ohm resistor. Now earlier we said you can avoid all this by just running your LED at its rated voltage forward. So if your voltage forward is 3.2 volts and you give it 3 volts, and if it comes on at 3 volts, it's dropping beyond what the LED is rated at. I mean, in other words, it's minus 2 volts. So the amperage through your LED is the 0.02, and you don't have to put a resistor in the circuit at all. You can just run it like this. Again, the tricky part of this is all of your LEDs have to have the same voltage forward, or you're going to have multiple power supplies. This is how Karen powers mostly all of her models. She does it from batteries, and she just puts 2 1.5 volt batteries in a battery pack and runs all of her LEDs that way at 3 volts. Batteries are also very forgiving running LEDs because batteries represent sort of a load in their own right. And I'm actually running all of the switch lanterns on the railroad this way because I'm using the little teeny tiny surface mount LEDs, and I'm just using ones that are all rated at right around 3 volts forward. As long as they come on with my 3 volt power supply, I figure I'm good to go, and it saves me from having to wire in a whole bunch of resistors. And because most of the LEDs that we're getting are rated at right around 3.2, 3.5 volts forward, We just use these numbers here as a jumping off point if we don't know what we've got and we just sort of want to guess. And 9 times out of 10 this just works. If not, then you need to figure out what voltage forward you're actually rated at and figure out the appropriate resistor. I'll just grab one of the LEDs that we're working with because they're cheap, and I'll hook it up to the power supply, and if it comes on and seems to be happy, I'll just leave it like that overnight. And if in the morning the thing is still on, I'll say, I guess we're good to go. And sometimes when you buy an LED, it will already have the resistor soldered to the LED. These little screw-in lamps don't look like it, but in the base here, they actually have the appropriate drop-in resistor so that you can just hook these up directly to 12 volts and they just work. Now, typically, a resistor won't say on it what it's actually rated at because they're too small for that. And so a million years ago, they came up with a color coding system to tell you what the resistor actually is rated at. So if we look at the resistors that we're using, quite often we'll be using like a 100 ohm resistor. So that's brown, black, black, possibly brown, black, 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 something like that. If we're using the 440 ohm resistors, that's yellow, yellow, black. So it isn't too hard to figure out. And LEDs, especially the little tiny surface mount LEDs, can be tucked into really out-of-the-way places. In this case, Karen has stuffed one inside a little tiny lamp in this O-scale house. So you can do things like that. You just sort of have to know how to use the LEDs because, boy, they're not quite like working with light bulbs. Anyway, now that we've gotten some of the nerd stuff behind us, next week we're going to be following up with the more creative aspects of working with LEDs and some of the fun things that you can do. And so hopefully you'll want to follow along and look at that. And the easy way to make sure that you're notified of that is to be a subscriber by clicking on the upcoming blue button. Zoink! Right there, the blue button. Well, we're not sure how you found this video on the internet. We hope you didn't find it boring. And Karen and I will see you on Sunday because we have some fun stuff. See you then. Bye-bye.